to Bald Guy DIY. In this video, I'm going to try a few different methods to see which is the best to make 3D printed PLA parts stick together. So I've had several different occasions where I needed to join different 3D printed parts together, and I've tried a couple of different methods and things that I've seen online to try out. I want to show you today the difference between plastic welding, using PLA glue sticks, and using an adhesive CA type gel in order to join the pieces together. So here's my little test. It's definitely not scientific, but I hope it helps you if you need to join your own model pieces together. Let's get started. In order to try out these different methods, I printed off a bunch of these 2mm thick 25mm by 75mm strips in order to glue them together. First method I'm going to try out is the plastic welding method, which includes putting some filament inside a rotary tool and spinning it up to friction weld the pieces together. Now I have seen this done before with just filament put into a rotary tool and spun up, but my rotary tool only takes 1/8 inch bits. So I've had to 3D print some little welding rods, I call them, which are basically 1/8 of an inch or just over 3mm in diameter, and they're just little sticks that are going to fit that properly and also be nice and solid for the plastic welding process. To start by loading them into the little rotary tool. I've removed the guard and things that's going to get in the way, and then just tightening that little stick down and making sure that it's secure inside the collar. Just going to turn it on, make sure that it spins nice and clean and that it's not flopping around or giving a lot of displacement. Next, I've got my two pieces overlaid one on top of the other, and I'm simply going to turn on the tool and push it against the two surfaces. The friction and the heat that friction creates is what melts the filament and causes it to fill into the material that you're using. Now if you use PLA for all the components, they all have the same melting temperature, so you're actually going to fuse them together. Just like welding metal, you're going to create a fusion where both pieces you're trying to secure are going to melt, as well as the filament that you're pushing into it, and the end result is that you get a nice hardened strong joint where it's hard to pull them apart. You know, if you really put a ton of pressure on, you'd break it. There you can see I haven't gone all the way to the edge, so there's quite a bit of flex there, but it's nice and secure, and with some practice you can make the look of the whole thing much better. Just like with welding, there's a lot of finesse that goes into just making it look good, and in this case I tried a few more times, and every time I did it I got just a little bit better result. Going slow, allowing the filament to pool a little bit as you're going, it also gives it a little bit nicer of a look, maybe just a little bit more robust and like an actual metal weld would look like. And you know, of course, by pushing in a little bit harder and going a little bit slower in your progress is what causes that to pool up there. You're really not using very long of a piece of filament, or in my case the 3D printed welding rods, so you're really not able to do that much of a stretch for each little piece that you're using, but you know, you can probably get 2 or 3 inches in one pass as long as you know you go with steady progress. As you can see, each time I do it, I get a little bit better at it, a little bit smoother. So if you're trying this out on your own pieces, I would definitely give a few attempts to make sure that you're getting a good feel for what it takes to make a nice, consistent little plastic bead as you weld along. I chose the red and black for the sake of contrast, but here I'm just going to do 2 pieces of black so that you can see what that looks like. And you can't really see it at all as I go here. Maybe you can see a little bit of the shine from the filament being hot and melted, but you can't really see it, which is the whole point. If you're going to be welding together 2 pieces that are the same color, it's nice to use the same color filament, and also that way you're going to get a much less noticeable joint. The thing that I also love about this is that because it's plastic, it's easy to go in after and you know, tweak and touch up, maybe with a soldering iron or something else, to just make it look a little bit more uniform or to lower any high spot. The next method I'm using is with some 3D printed glue sticks. I simply printed a stick design that matched the dimensions of a glue sticks for this little glue gun. But as you can see, even with a high temp glue gun, it doesn't grip the PLA the same that as a glue stick, so you have to push it and force it. Now even after letting this heat up for quite a long time, about 40 minutes, you really can't push out very much at a time before it cools the barrel and it doesn't heat the plastic enough. That's the biggest problem that I found with this idea. I saw it online and it looked like it would work really well, but the glue gun doesn't get hot enough, and so the PLA won't really fuse the pieces that you're looking to join together. You know, it's great that it's the same color, but it really doesn't do any kind of job at all in order to join these pieces together. As you can see, because there's no bonding actually happening there, it flakes right off. This was a fail right from the start. Sounds good in practice, but you'd be better off using a colored glue stick, which some people sell, black or other colored glue sticks, which would work a lot better. My preferred CA type compound is actually a Gorilla Gel. I really love the gel over the regular CA glue because, as you can see here, it really builds up, which means that with a 3D print you often have, gaps and voids and uneven surfaces, even if they're as smooth as you could print them. But this gel will fill in all of those little gaps and give you a better bonding surface than you would with regular CA glue, which flattens out completely, fills the gaps, and then it doesn't really give you the same kind of contact points that the gel does because it's a lot thicker. So I just applied a liberal line here, stick my two pieces together, and like all crazy glue or quick dry type CA glue, you need to wait 40 seconds, a minute in order for it to bond and cure properly. Now, of course, if you read the directions on these bottles, it will tell you that the full cure doesn't happen for 24 to 48 hours. So there's no point in giving it the ultimate stress test. But I just wanted to compare it here and show you that in even just a minute of pressure, you do get quite a strong hold, and the pieces don't easily come apart. I've glued several pieces together before, even for my CNC machine. They hold very strong, and without really applying an unnecessary amount of force, it's not going to come apart, and it's going to remain in the condition that you want it to be in. So if you're using something, even that's going to take quite a bit of abuse, proper adhesion, some CA glue, or in this case a Gorilla Gel, really fills in those grooves. As you can see here at the edge, it is lifting because I didn't get the glue right to the end, but the overall pressure and flex, it does hold together quite nicely. There's really only two viable options that I found here: the plastic welding with the rotary tool and a Gorilla Gel CA type glue. So as you can see, the PLA glue sticks were quite a fail for me. I was using a high temp glue gun, but really didn't make a difference. Did not get hot enough in order to melt the PLA and really get any kind of fusion between the other parts. Now, maybe there's a higher temperature glue gun you could use, but for me, I really didn't see that to be a viable option. Between the plastic welding and the Gorilla Gel, I really like the Gorilla Gel because you don't need to set up, you don't need to print any little plastic welding rods or anything like that. But the only downside I could see to it being that it really isn't going to have the same properties as the PLA plastic you're joining together. So if you needed the right amount of flex, or if you needed temperature properties to be consistent for both the material that you're printing in PLA and also the adhesive, there could be some differences there because the Gorilla Gel is made out of something entirely different. The plastic welding, it's a little bit finicky, but you can get better at it the more that you do it. However, I think it really shines where you need to have the same properties of the material all the way through. The plastic weld itself is going to have the same flex as the PLA compound because it's PLA. And the other thing is, it's going to have the same temperature characteristics, and so it's going to expand and contract at the same rate that the rest of plastic would, and it would also melt at the same temperatures. I think that could be really handy depending on the application, and so I would try either one of these depending on what you see would be the better benefit to you. So there's a couple options for you to try. If you're needing to glue or secure two printed parts together, I hope that answers the question for you and it gives you some idea of what to try in your own projects. If you find these projects helpful, let me know in the comments. Give the video a like and subscribe to the channel, checking back every week to see as we post a new video on a wide variety of DIY topics and interests. Until next time, in all your DIY projects, stick to it and don't be afraid to be bolder.